Good day, good night, good morning, good evening, good afternoon, wherever you are, whatever time it is. Welcome to another one in our continuing series of videos on topics in the C-Sec Math syllabus. In this video, we're going to look at the topic of combining fractions, combining algebraic fractions. Alright? And in this video, we're going to focus specifically on the case of two fractions, because combining two fractions, as straightforward a matter as it is, causes a lot of people a lot of problems. So we're going to deal with that specifically in this video. Alright? Sometimes you have to combine two fractions in the course of solving another question. Sometimes they'll give you two fractions to combine by itself, just to show that you could do it. Right? And in many cases, these fractions could involve letters by themselves or a combination of numbers and letters. So, the best way to explain this is to give you the general theory and then do some examples as we always do. So, without any further ado, let's get straight to it. If I have two general fractions, let us say a over b plus c over d. Alright? And we want to combine these two fractions. Now this is just the mechanics of it. Alright? I'm going to explain this without going into too much detail of the mechanics of LCM and all of that. Alright? So we have this fraction here. If we want to express this as a single fraction, meaning one numerator, one denominator, as I tell people all the time, you cross multiply across the sign. Alright? Cross multiply across the sign. So it will be a multiplied by d minus b multiplied by c over, and then you multiply the two denominators at the bottom, b minus d. Alright? And similarly, we have the same two fractions with the sign change. Let's say a over b minus c over d. Right? That would be same story. A by d minus b by c over b d. Alright? So the concept is the same. The only thing that changed between this one and this one is the sign in the numerator, which would follow the sign that we have here. Now of course, if this c was negative, right, the negative sign in this case would have changed this to a positive, and similarly, the positive sign here would have changed this to a negative. But don't worry about that too much. You will deal with that in the course of doing questions. So basically what we're doing here is giving you the basic mechanics, and then after that we provide questions for you to practice, and of course you have recourse in the comment section accompanying the video to make your comments and to get feedback from other people in the group. Alright? So having explained this, the next step is to just simply do some examples. So let us do some examples. Alright? So let us go with some abstract examples. So let us say you have 2a plus 5 minus b over 7. You could get that in a CXC maths exam, right? You could get that in a multiple choice. You could get that in a paper 2, and possibly conceivably in a paper 3 as well, now that they have the paper 3 coming on stream. Alright? So again, you cross multiply across the equal sign. 2a minus 7 is 14a, 5 by b is minus 5b, and of course your denominator is 7 by 5 is still 35. And that's it. One line and your story done. Alright? So once you know your tables, you cross multiply, bam bam bam, end of discussion. Alright? And let's take another random example. If we have, let us say, let me see, x plus 5 over 3 plus 2x minus 7 over, let us say, 2. Yeah, right? And they ask you to make that into a single fraction. They like to bring that as a question, and as often as they bring it, it still causes people problems. Alright? So the aim is to eliminate that for you looking at the video. So 2 into x plus 5 is equal to 2 brackets x plus 5 plus 3 into 2x minus 7 all over 3 by 2 is 36. Alright? So we're going to rub off the top here now and finish this question. Alright? So we're finishing this question in black ink on the top. So your line would be let's see, 2x plus 5 is 2x plus 10 plus 3 into 2x minus 7 is 6x minus 21 all over 6. So in the interest of space, I will just say it out, right? 2x plus 6 is equal to 8x. 10 minus 21 is minus 11 all over 6. And that is the end of that particular discussion. Alright? So you have the opportunity. The advantage with the video is that you can always rewind, pause, slow it down, stop, etc., to see the mechanics explained as we go along. And then of course the next step is to just practice. So suppose we change this sign from plus into a minus, right? As you would very often have. Very often you get that. You get two fractions, but instead of adding, they ask you to minus. Right? So the mechanics are the same. 2 into x plus 5, 2 into x plus 5. 3 by minus 2x minus 7. So basically what you do in this case, you leave the minus sign here. Right? So it will be minus 3 into 2x minus 7. So this minus sign is the same as this minus sign here. Right? And of course, with the minus sign here, everything inside here will change. So this will be minus 3 by 2x, which will give you on top here, not plus, but minus 6x. Right? You'll have minus 6x on top here, and minus 3 by minus 7. So we just make this 7 a little more legible than that. Alright? Minus 3 by minus 7 will give you, instead of minus 21 here, it will give you plus 21 here. Big difference. Alright? So that with this fraction now, answer will change. Alright? And it would now be 2x minus 6x, which will give you minus 4x. Right? And 10 minus 21. No, 10 plus 21 which will give you plus 31. So you get minus 4x minus 31 over 6, which you could write over as, I'm going to take out a space in the middle here now. You can write that over as 31 minus 4x over 6. Right? Just for the sake of aesthetics, elegance. Right? Arithmetic sophistication, if you want to call it that. Alright? So, with a couple straightforward examples, alright, I explain how to do it, alright, and now we're in a position to go straight ahead and do it. I just want to encourage you, right? Whatever the fractions look like, it doesn't matter what the fractions look like. Don't be intimidated if some of the fractions look unfamiliar, if it's looking hard, right? Once you have denominator 1 over the numerator 1 over denominator 1, plus or minus numerator 2 over denominator 2, then the procedure is the same. Alright? You cross multiply across the sign, whatever the sign happens to be, plus or negative. And of course, paying attention to your negative signs. This right here is a very common mistake that people make. They have the idea correct, they execute it on top here. But to make the transition from here to here is a problem. Alright? So of course, as always, pay attention to your negative signs. Alright? And in doing so, in the course of your practice, the idea is to take yourself to a place where anytime you see this on an exam, you know immediately that's instant marks, sure marks. You can work it, get it out, and you know the answer correct. There's absolutely no doubt in your mind that you got it correct. But what I want to discourage you all from doing is taking shortcuts. There is no shortcut in this thing. You have to do the work, you have to put in the effort. Sometimes it's not going to be easy, it would not always be pleasant, but you're doing this with a long-term goal in mind. Alright, so there you have it. Addition or subtraction of algebraic fractions. Go right ahead now and get it done.